Are you looking to synchronize data between one system and a database? In this tutorial, I'm going to walk you through a common issue we see when moving imperfect data in between systems, and how creating a database Upsert API can help prevent errors and keep your database data clean. Let me describe the common issue first. In this scenario, we're going to pretend on the left here we have a registration system. For this example, we're going to use customers. So customers can register using any type of application. For example, this could be an e-commerce site, maybe a WooCommerce or a Shopify. And what happens is when the customer registers, we need to take that event and data, and we have to move this data back in-house into our master's customer system, which in this case is going to be a database. And usually when you're doing any type of sync jobs, what happens, you capture the event in the source, and then you just copy that event data into the database. So for example, say we have a registration page on our e-commerce platform that whenever a customer signs up, we're going to take that customer and put it into our customers table in-house. So for example, you could say in-house, we already have a customer called Bobby Ryan. For now, we're just going to use two attributes, the name and the email. So a new registration comes in on our website, new customer registers, and we get a new registration event. Common solution for this is to create an API at the system layer around the customer's database that accepts the events and then writes it to the table. So for new registration, this translates into a request to insert a new customer into the database. And now after that takes place, we'll have now in our customers table the name Craig Anderson. And usually what the API will do is it'll return back a 201 success message back to the system that sent the new registration. Now on our registration site again, say now we have an update registration, and this could involve someone logging into their account and say updating a piece of their profile. Maybe we had a section where the customer could enter in a bio, and the customer updated the words in that section and hit the save button. That would trigger an update registration event, and that could be another API call to the customer's API. And in that case, we would update the Craig Anderson record and we return back a 200 success. Seems pretty simple enough. However, in reality, we start getting events like this. Well, now what would happen if we receive a new registration with the name Bobby Ryan? You would think that this would never happen because how could we get a new registration for Bobby Ryan if it already exists in the customers table? But in actuality, this is a very common case. This could happen for many reasons. Let's say our organization has another system, say a call center system, that also creates registrations. And Bobby Ryan happened to call into our call center first before they went onto our website. And then our call center team, he made their account for them, which entered into the customers table. Or what I see quite frequently is that the registration system was actually a newer product. They had an old registration system previously, and when they did the migration, they missed a bunch of records. So when the Bobby Ryan new registration event comes into our customers API, what's going to happen, it's going to try to do an insert into the database, and it's going to return a 500 error because it's going to say that the customer already exists. And another case that I see quite often is when we have an update registration event for a name, such as Cody, when the customer doesn't exist. I've seen this happen in situations that we're dealing with multi-threaded applications, where the events from the customer on the website are really quick, where an update registration will be triggered right after a new registration trigger. But as it's processing through the API levels, we actually receive the request to update the database before we receive the request for the new insert database call. And typically what our API does is return back a 404 because the customer wasn't found when we tried to update it. If we look at these four different events and the responses, you may think, well, that's a well-designed API. But in practice, what's happening is that if your team is responsible for the customer's API, what you're doing is that you're sending back errors to your calling client. Could be another team, could be a process API that you own as well. You're sending back errors and putting the onus on them to take action when really the error is because the data inside your database. If we could solve this problem on the customer system API level, then other calling applications to this API won't have to handle the 500 and the 400 errors as well. And also, when the calling client receives a 500 error, they can't necessarily assume that a new registration already exists. And a 404 doesn't necessarily mean that the customer is not found. A 404 could be because the system API is down and you can't find the endpoint. And a 500 error could be because the database, something went down on the database. So having the calling client create logic based on your different error handling is a little problemsome. So if we can solve this on the system API, we won't have to throw errors, put the onus back on the calling client to take actions, alert monitoring applications. We can keep our logs clean. There's a bunch of great benefits if we can handle these minor data related issues quietly. So let me show you the API structure of the system where we just throw back errors to the calling clients. So for example, if we have a new registration or customer event, we create a post on V1 customers where we accept the customer object and then we convert that into SQL code that will insert into the customer table. And then typically we'd create another API which handles the update of registration or customers, and we put that under a put method in V1 customers with the customer ID. And sorry, this would be an update existing customer. And then we convert that into SQL code, an update statement, and then we'd update the existing customer data. This would work in theory, but as I described earlier, it's very rare to have two systems completely in sync at all times. So to solve this problem, what we're going to do is we're going to create what is called an Upsert API. So in this case, instead of having two endpoints, we're going to have one. Could be a post, could be a put, depending on who wins the architectural discussions. And now we just have a single API, which we call an Upsert. This again is a system API and it wraps our customer database. But in this case, we're going to add some logic, which will define whether it's an SQL insert statement or an SQL update statement into our database, instead of forcing the calling client to create the logic. The most common database languages do have syntax that allow you to do upserts. In MySQL, they have the onDuplicate key, where you insert it unless there's a duplicate key and then you update it. SQL Server has the merge functionality, as well as Oracle has the merge syntax as well. However, in Endpoint Studio, you're pretty limited in the database calls you can make. So in our case, we have to separate the logic using Mule flows, but this also gives us flexibility, error handling, logging, stuff you wouldn't be able to do if you encapsulated all your logic inside an SQL statement or a procedure call. Contest time, I'm going to be giving away $30 US for the first person to provide the answer in the comment section below. We talked about how MySQL provides syntax that allow you to make an update database call directly using their query language. I need you to create a single MySQL statement that will reproduce the same logic we're doing in this tutorial, but strictly using the SQL language. To answer correctly, I'll have to be able to copy and paste your statement into a MuleSoft database connector and get the same result. If I heart your comment, that means you've won, and then I'll be in touch with you to PayPal you the money. Good luck. And now we're going to go into Endpoint Studio and show this API with Mule Code. Today we're using Endpoint Studio version 6.4.4 and the Mule Runtime 3.9.0 Enterprise Edition. As you can see, this looks very similar to our last diagram. We start off with an HTTP inbound endpoint on /customers, allowing the method post. And then on our connector configuration, we're on port 8081 /v1 as our base path. First thing we do is we convert our input stream into a Java object for easy access. Print out a logger just to say that we received our request, and then print out our email. Print out the email of the payload. I'll show the payload in a second. And then the logic to determine whether we needed to insert or update comes from actually this query database. So what we're going to do in this step is we query the database to see if the record already exists. So we take the email, which is our unique identifier, and if it returns back that we found it, we can go into the flow to update, and if it returns back that we didn't find the record, then we would go back and then we insert it into the database. And that's basically the two logics. So let me show you what the input payload looks like. We're in Postman. So we're on port 8081 v1/customers. And this is what we have. You could say a customer or registration. This is the object we receive. So we have an email, first name, last name, and we have an optional field, which is biography. So we'll say that this is like a profile option when we're registering. And I got to talk about the database. So our database is a MySQL database. We have a few records in there already. So we have our auto increment number, an email, which is actually our unique identifier, first name and last name, and a biography optional field. This is the table customers. Actually, let's clear this to make this easy. Let's put a breakpoint. I'm going to run this in debug mode. And let's get our payload set up first. So we're going to say email is Craig. So our server has started up. Let's send this. So we have our 4 fields inside our payload, inside our hash map, and then it stops on our query to see if the email craig.example.com exists in the database, and we actually take the result, which would be an ID, and we're storing it into the customers found variable. And we do this because we don't want to lose our payload, so specifying this will allow the input payload to exist in the output payload. It's the same idea if you have older versions of Anypoint Studio, or if you're in the Community Edition, as if you were wrapping it around and in richer scope. So the result of that query gets put in the customer found, and then in our choice, if we found a customer, so if the array list is greater than 0, then that means that customer already exists. So then we take this upper flow here to write in the database, and if the query comes back empty, that means the customer doesn't exist in our database, and then we take the lower path to insert it. So the database is empty, which means we should take the bottom path, which we do, and we went through and we received the result. And let's go into our database, refresh, and we have the Craig Anderson record in there. And now let's say we have an update request, but this time the customer put in a biography field. Let's send it. Query the database to see if the email exists. This time it does exist, so now what we're doing is creating an update SQL field, which we're updating the customers table with all the fields in our payload and in our unique identifier to identify which record. Refresh, and let's see if that biography changes. Perfect. So it was the exact same endpoint, but in this case we did an insert SQL instead of the update. And this is what's called an Upsert API. So if we look back on our initial problem, there's no longer distinction between new registrations and update registrations. We just accept every type of registration, and we determine on our side whether it's an insert or an update. If this new registration came through for Bobby Ryan and Bobby Ryan already exists, our existing customer will get overwritten. There's no error thrown, or there's no duplicate Bobby Ryan records in our database. For the update registration, our Upsert logic will determine that Cody doesn't exist in our database, and it will insert it for us. One thing we actually didn't do is specify our response codes. 201 status code usually means created. Ignore the success here. And 200 usually means success. So let's implement that on our API. So we're going to put a property here. And the value we want it to be an integer, so we'll keep it inside the Mule logic. 201 is created. And update. So let's save this. Should auto redeploy. And let's put a new name in to make sure that we create a new insert. Becomes an insert. Set the outbound property to 201. And hopefully we got, yes, we did a 201 created. And you may not think these HTTP statuses are important. However, you never know what the calling client might do with this. They can now implement logic based on whether we actually created a record in our database or updated one. One thing that's not really nice is this is actually the database response object, Java object. So let's clean that up. There's two common ways when you're replying to send back on an API. A lot of people like to send back null. And this is very easily to do. You could just create a transform message setting the payload to null. But what you could also do is return back the object that was just created or updated. This could be very useful for, say, examples where you just created a record and you're returning back an ID and that ID gets stored. Or if you're calling it from another Mule application, it's kind of a nice flow when you don't have to save a payload, call an HTML endpoint, and then restore the payload. Because when you get the object back, you can just continue through your flow. So for this case, what are we going to do? Let's just return back the payload. This actually can be done quite easily because this database connector will wipe our payload. We could store it and reload it, but a little quick way to do it is, say, let's put a target here as flow vars, and we'll just make up something called result. And we'll save it. And what this will do now is take this actually, which seems to be like a number from the database call, put it into the result variable, which we'll not use. You'll see our payload is 4 items. Our result actually, becomes the integer 1, but our payload stays the same. And then as we go through it, actually coming back as application Java. What we could do in that case is, let me think. I guess we could, just for the sake of the demo, we could put a transform message here that puts the payload back out to a JSON, and then just a simple payload. There we have our JSON back. As you can see, this output is really just a copy of the input. As I was saying earlier, it'd be really useful to have the ID that was created from the database. Because this is MySQL database, you would have to make another call to the database and for using the function last inserted ID. So you'd have to make another call for select last inserted ID, it'll get back the ID that was just created, and then you can enrich it into the payload. Or also what you could do is just another query. I really should end the video now, but let me just show you how I would do that. So go back to design, add another database. I can't really use the last insert ID in this case. I could use it in the insert flow, but an update, it's not going to give me the ID. And just to keep it consistent, let me just do another query back to the database to get the ID because I'm using a unique field. So we're going to go to select. This time I'm going to put the target so I don't lose my payload. And then I need to add it to my response. I actually don't know. I know it comes in an array. I don't really know what it looks like. So let me just do a breakpoint. We'll do a quick test. It's an ID. It's a linked list with a hash map. And it's the first entry because the select could have more than one. But we know email is unique. So it's going to be the first one. So actually, let's just figure this out here. So it's flowvars.id. That brings us a linked list. So we want the first result. And then that's actually a hash map. So we should be able to get the ID just from there. Perfect. Okay, so we're going to take this. And just adding the ID doesn't match up well because our payload is a JSON object. So we're going to concatenate a JSON object, and the key is going to be ID, and then we're going to paste what we got from our Mule expression, and that should be it. Save it. There we go, perfect. Our ID came back with 7. And that 7 could be very useful to the calling API. And there you have it. That's how we took two common APIs, one for update and one for insert customer events, and we combined it into two and added that logic behind the system API so that we won't have to throw back any errors to our calling client, and we can handle any data out of sync issues quietly. I hope you enjoyed this video. Any questions or comments, please leave them below, as well as any topics you would like to cover. Thanks for watching, and see you next time. Peace.